Hello, everybody. So nice to be here. And I want to speak today a little bit about Kotlin and about Rust and our all-beloved Kotlin multi-platform. Or even better, I want to show you how we can write code once, in theory, and ship it to many, many platforms, in theory. So first of all, who am I? I can look there. I'm an Android engineer, as most of you, at a company called Lichtblick SE. You might never heard of it. That's fine. That's totally normal. We are a green energy provider. In fact, we are one of the oldest in Germany. So at night, I'm normally tinkering with Kotlin multi-platform. So if I have the time and don't want to sleep and I'm bored and I don't have friends, then I do that, like writing compiler plugins or tinker with KSP or something like that, what normal people so do. And if I have free time, I tinker with Rust. And yeah, I must be a very bored person, I know. And as well, I am an organizer of the Kotlin user group in Berlin, as well as of the Rust user group and the Extreme Tuesday Club here in the city. So, and I will talk about a repository I have on my GitHub page. So if you want to follow up this talk, please scan this QR code. I will also upload there my slides later this day, so also with all the pictures where I have from, so you know where to find them. Okay, what I will speak about. First of all, the question arises why we ever want to integrate Rust and Kotlin, right? Is there any need? Is Kotlin not enough? Is Rust so much better? Do we even need that? So the second question I want at least to poke is how we integrate Kotlin and Rust. Because that's why we are here, and if we maybe think, oh, that's a good idea, we also need to know how we do it. And the third point is Rust is currently on a hype train, if you realize that. And for me, as somebody which is fairly new to the entire community, it's actually a quite experience to see how a hype of a language takes off. If you are longer in Android development, you might have seen that with Android itself, but for me, it's an entirely new experience and to see it live and to observe it. So, and be part of that, that's also a thing, right? So what this talk is not about. First of all, I will not make a Rust talk. I will not show you how Rust works. I will not show you or explain what a borrow checker is or something like that, or what lifetimes are, or the scoping works. That's something for an entire different talk. That's not what I want to talk about here. And the second thing is I will not give you a ready-to-go solution. I will give you a proof of concept, and that's it. So you can clone my repository. I'm currently working on something which you could technically put into production, but I'm not there yet. I'm far from it. So don't expect that from me. And also, what I don't give you is a silver bullet. I can't solve every problem, but I can solve some of them. So feel free to contribute and to solve others. And if you think what I'm doing here, or if you are here with the expectation, what I'm doing here is super complicated, super complex, and only a few chosen can do that, you're wrong. I do something very, very dumb, and with 5 minutes of your time, you might have done it yourself. But I was just bored, you know? So please expect something super special. Anyways, and since it's one of my first talks ever, and I heard you should make a joke or something, and I'm German, I asked ChatGPT what's funny. So that, can you see there? And yeah, there was a joke in a joke. I hope you got it. Anyways, let's start with the first question. Why or what we are talking about when we talk about multi-platform. What is it? And what I will do here is an arbitrary definition, since there is no definition per se. What is cross-platform? What is multi-platform? Everything is munched together, and for me, I just make their arbitrary separation of both terms. First of all, when I speak about multi-platform, I mean the capability that we can integrate with a platform on a native level, like that we have in Kotlin for Swift or for iOS, Objective-C bindings, so we can communicate with an iOS device over them, and not like if you write, for example, React Native, that you have to write a wrapper which you bridge into the framework. That would be, in my opinion, cross-platform. The second thing is that you can, for both, write code once for cross and multi-platform and ship it to multiple platforms. But the difference is that you have to be aware as a multi-platform engineer that you are sitting on a concrete platform and not that it's working all the same for every platform, like with React, for example. And the last point I want to make is if something is not working in the common space, you just fall back to the platform itself. Like, what example would be good? Maybe if you are tinkering with numbers, with big ones. There are different libraries, for example, for iOS or for Android, or let be it web. Yeah. So you need the capabilities there to fall back to the platform to tinker with them. And that's something you can't normally do in cross-platform libraries. You need something which bridged into it, which then deals under the hood with those problems. Okay. So what is the goal of this entire thing? I mean, we do the thing because we want to write code once and in one language, in the best case, and ship it to every platform we can imagine, right? That saves time, that saves money, and that also saves a lot of stress, in theory. But in reality, it is so we have to deal daily with multiple languages, be it Swift, be it Kotlin, be it TypeScript or something, and that's typically nothing we really want. Yeah? And other thing is that the language also fits our personal behavior or bias. For example, if you are more like, I want to write functional code, like in Haskell or in Scala, the language should support that, right? If you want to make more objective-oriented programming, that's another type of personality, and the language should support that. But finding something which can support both or even more is a hard thing. So, and the second goal we have that we want to build over the entire stack, from the front end to the back end, maybe even only front end, maybe even only back end. And you should have the capability to do that in one language. In theory, you could do that also in JavaScript, right? But do you really want to do that? Since JavaScript's intention was never to be designed as a backend language, it was always designed to be a browser language. So you miss there entirely certain capabilities, like threading. You have to put them afterwards, and that makes things sometimes really a hassle. That's something you want from such a multi-platform language. You can do that over the entire stack without even caring about. And the last thing is, if you really want, if you go multi-platform, the actual goal is that you free up time, right? You want to free up people, capability, damn it, sorry. I'm a little bit nervous. Capacity, you want to free up people capacity so that you can spare a little bit human lifetime on a project and put that human lifetime at another project or another aspect of the project to use. That you could technically do if you have engineers which can work at the same code base for the same problems over different devices, and not like nowadays that you have the same problem to implement in iOS alongside like with Android or even web or even worse on Linux machines. So, and the better question is what was my initial problem here? I was working on a project which had to use encryption. And the problem was actually that our platform was meant to run on web front end, on an Android front end, and iOS front end. So we need to find an encryption algorithm which is supported over all the platforms in the same way. And we also had to fulfill some legal requirements. And there are the limitations. Because the browser doesn't support anything so much like iOS or like Android. And then what you do? You technically don't have a handle in multi-platform right now. So that's why I started with Rust. So, but Kotlin in itself is, for sure, the best language in the world, without a doubt. I think we can easily agree on that. But as I already said, sometimes you miss their functionality, which you somehow need to patch in. And ideally, you don't want to write it yourself, especially things like crypto algorithms, because they can be super flaky or super hard to implement. And also, sometimes you need some bindings to low-level tasks. Like if you do machine learning, and you have to interact with TensorFlow. You can't do that in Kotlin very easily. There are built entirely libraries around that to bridge that problem. But sometimes you feel like that's wrong. I don't know what's happening there, and you want to go natively, and you can't, or you don't have the possibility right now to do that in Kotlin. So you could fix that with Rust. And another constraint might be resources. Like imagine an iPhone, not an iPhone, an Apple Watch, where you have, or where the binaries can only be in a certain size, or where the memory is very limited, and where even the Kotlin runtime for Kotlin native is that big and uses up so massive capacity that you are running there in limitations. And you can overcome that with Rust for reasons which I explain later. And sometimes the support for target is not good enough. Did any of you ever try to run Ktor on Windows machines? No, I did. And I can tell you it's sometimes not nice, because you have to use something like curl, which is not always the best choice for reasons. And also there are some other limitations. And you will have that also with other libraries. And you will see once the WASM support is shipped for Kotlin itself, libraries will take time to adapt to that, and you can't just use it right away. That's a bad thing. But you still have to fulfill your business requirements, right? So that's why I want to speak about Rust in the end, which is a memory-safe language. You might have heard that. And that's amazing, because Rust is a low-level language like C. And if you ever had the pleasure or the pain to work with C, that's something you want to have, to be memory-safe. You don't want to tinker with allocation and remember if you have allocated their memory and to free it there. Rust does that for you at compile time. And that's the second big thing about Rust. You get abstraction without overhead. That's also a thing in C++, but Rust also gives you the memory safety, which you don't have in theory in C++ by nature. So both together are very great, but you get more. You get concurrency without fear, because also there the compiler can help you, since he tracks all the allocations you do and says, oh, if you use that thread here, you make something wrong. You might mess up the memory. Please correct it, which is a great feature. And lastly, we are still speaking here about a low-level language, right? It's really like C. It's not assembler, that's more low-level, but it's still on the C level. It's not like that you have a virtual machine in between which takes care of many, many things. But if you ever had the pleasure to work with Rust, you will feel it is more like high-level, but you're still working on memory base. It's just awesome. And the WASM support. If you ever had in your life to tinker with something like cryptocurrencies or Bitcoin, whatever, you will see everything is written in Rust, because Rust has a supreme WASM support, and you can just ship it to browsers or somewhere else. And that's a feature we want and we get now in Kotlin, but Rust already has it. That means also many, many dependencies you can use are already there. So, but what's the problem with Rust? Rust is still a low-level language. That means you can mess up the memory if you really want to. And people sometimes or tend to do things which are not good for them, like tinkering with memory, because they get frustrated, because they don't understand the language, which I totally get. I was there myself. But that means if you want to put it in production and you make something you shouldn't do for reasons, you might mess up your product. That's nothing you want to do. The other thing is, because you have to take care sometimes also about memory or other stuff, Rust introduces a certain type of complexity. You normally, if you do something like mobile, you don't have and you don't and you want to avoid. So it might be not a good choice. Oh, damn it. That was too fast. And the tooling for mobile isn't there. There are some crates you can use. I really can recommend, for example, the NTK crate for Rust, which is great, which brings all the functionality for Android you want and need. But aside from that, like a proper debugger or a proper emulator or an integrated IDE isn't there yet. I know people working on that, but if you are in the Rust community, you will see many people are working with Vim for a good reason, because the Vim plugin is still better, even in my opinion, than IntelliJ. But things getting there, hopefully soon. And the last point, and that's the important point, do you really want to write a front end in Rust? If you ever saw Rust, you will probably agree on me on that point. You don't want to, because Rust isn't meant for front-end in the end. You don't want to make declarative UI in Rust, for reasons. People are working on that, but I'm skeptical that they get there. So is there more we have to consider? And yes, there is. I'm sometimes speaking with other people. That happens occasionally. Also with people from companies like team leads, tech leads, CTOs, and stuff like that. And they told me about Rust. That first of all, you have business needs, for sure. And business needs doesn't need to match up with the tech needs. That also means Rust can be a requirement. I can tell you from a company, which name I can't say, but they just use Rust for Android and iOS and the backend because they say, oh, we want to be as climate neutral as we can. That means we have to reduce our memory footprint. We have to reduce our CPU cycles on the devices. So we need a language which has zero overhead. So they're doing Rust. It's a choice. Let's put it that way. So the other thing is Kotlin is widely adapted. If you even decide as a company you want to go Rust with everything, because you can, you will have a hard time to find developers or engineers, especially for front-end, because there are no Rust people which doing front-end. On the other side, there are plenty of Kotlin people which are looking for a job right now. So you want to hire them instead, because you can hire them for cheaper money, right? And you don't have to invest money in them that they can learn the proper way to do the stuff they should do. And the last point is biases, goals, business goals. You have your team, what's the team bias? That's also a thing, and which problems you solve, right? You want to have the proper tool for the proper problems to construct the right solutions. That's always the thing we want to do, but businesses tend to forget that and say, oh, we have to do crazy stuff because it's a hype, right? So that's great. Let's do a little bit of code. And you might have seen that at one point in your life, right? I don't have to explain here anything. So we do the same thing simply in Rust. So the first thing you might notice is, where's my pointer? There. It's a little bit shorter, right? We have not fun, we have NN. It looks, oh no, that's fun, FN. It looks a little bit more mathematically, right? Oh, I have to really adjust to the clicker here. Math. Not math, math. So, and the other thing you will realize, because my IDE was super nice to you, is this print line with an exclamation mark. So if you don't know Rust, you don't know what it means, and that's fine. It's a macro. It's a thing we don't even have in Kotlin, because we don't need it, but Rust need it for reasons. Because everything is resolved in Rust at compile time. There is no runtime. So, like, if you want to put parameters in there. So what's the next thing? We look at functions. You already saw the main, right? Here, parameters, none. We have here a function call. We have here another function call with a parameter. That's normal Kotlin code. And that's actually a thing I really like. You can make return, if, else, and that's it. It looks super nice, super clean, super short. How that looks in Rust. Different. First of all, if you have to do some return values, you don't use this, you have two characters, not one. That's a little bit longer. If you want to declare a public method, you have to make it explicitly, because every method in Rust is by definition private for the external world. And another thing which you can see is simply you don't need a return in Rust. And if you really paid attention, here's something missing. What's missing here? The semicolon. If we go back, wrong thing. Here's a semicolon, right? That's very subtle. And the reason is very simple, because in Rust, everything, or almost everything, is an expression. So that means you can always make a return at every expression you write without even put a return value. And that's actually idiomatic Rust code in the end. And also we have in Rust less characters when it comes to if. It looks a little bit like Swift code at that point, right? So fair enough. And you can try it, it runs really. And the last thing we need for the talk is very easy annotations. You've seen that at proper times, a hello world annotation looks nice, right? Rust doesn't look very different, but I made here already one assumption. You can put here after the hashbang an exclamation mark, and that means something totally different. In Kotlin, we only, oh, damn it, that will be a running joke that I put the wrong buttons. In Kotlin, we only have this one kind of annotations. Maybe we can even put some payload in the annotation itself, but you can also do that in Rust, so no big difference. Anyways, that's all we need to build, aside from some domain knowledge, that's all we need to build a proper bridging layer. So structurally. So you have seen some Rust code now, so I can now assume you are onboarded. Great. So let's build an app. That's what we want to do, and that's what we do every day. We want to build an app for iOS, and I have a working demo which I show you at the end of the talk. We do it for iOS, we do it for Android, we do it for web, we do it for desktop, just because we can. The second thing is we want to show images of cats, because we all love cats, right? Cats are great. And we need the backend for that. So that's we do the backend also in Kotlin. And the last thing is we put some crazy long numbers in there. And if you ever used a big number library in Kotlin, you will have noticed the JavaScript part of those libraries normally has some limitations. The numbers can't be actually that big. It's a little bit bad, so we need Rust for that. Great. And last, we only use Rust and Kotlin. That's not entirely true. We have to do something in Swift, but we skip that because it's maybe 5 or 6 lines. It doesn't count, right? So let's build, or I'm not building that for real, but I can show you how, for example, the server could look like. No, that was right. That's not the server. That's something else. We code the server. So that's the project layout, right? Here we have the Rust thing. That's something for Gradle setup. That's some shared code we can share between the front end and the back end. So for example, if you have some data models which you ship at the back end to the front end, you would put it maybe there. And we have the back end. And of course, because we love it, we use Ktor. And the server might end up to look like that. We have our main function. The server, by the way, is already running because I was a little bit scared that it doesn't work. And then we put some stuff in there and our routes where we want to resolve. That's it. So from there, you can build up an arbitrary API, whatever you want. That's our server. Easy enough, right? So that was a shortcut. So next one. What we do now for JVM and Android. That's very easy. You might know that. That you might not know. We need Fluppygain. That's a generator. We need GNI bindings. That you might know. That you even might have seen when you ever had to bridge maybe C++ or C code into your Java. But we can do the same with Rust, but much better, because Rust provides you a crate for that and takes care of all the memory allocation and deallocation. So we don't have to touch there anything. We need our NDK crate so that we can do something with Android. We need a native library loader, which takes care for us that we have to that we can address and bind at runtime the right library. And we need, at last, Mozilla's Rust Gradle plugin, which takes care of all the compilation for us. We don't have to do there anything. Not entirely true, but almost. So let's go back into the IDE. So we are still in presentation mode. I hope you can all see that, right? That's big enough. That's cool. So I'm super prepared. I have here my Rust code. And I love structuring. And what I did is, Here I have my bindings for JVM. I was super nice and called them JVM, so we can just go there. And you already seen that now. You know, that's an annotation. You don't need to know what it is, what it does. That's an annotation. You know, that's a public function. That means you can, it's visible to the outside. You don't know what unsafe means. Unsafe is a bad thing normally, but we need it here. Unsafe means that the Rust compiler don't care here about the memory. Somebody else have to do that for us, and that's actually what the GNI crate will do for us. Extern means that we export something in a library. So in a dynamic or static library, in our case statically, because we have to statically bind them. But that's something you also might have seen in C, if you ever did it. And the rest, yeah, that's GNI. We have to put up very crazy names. That's just ugly, but that's the world, right? Full of ugliness. And the rest, we doesn't care. It's just some code. It does something and does hopefully the right thing. And I can prove to you that it does the right thing because I have tests. And how does it look on the Kotlin side? So what you want to see, Android or desktop? Anybody? Desktop. Okay, we go for desktop. Fair enough. We have JVM main. Ah, no, damn. I put it alongside. I was super smart at that moment. We have this air source, right? That's an arbitrary source set which I patched into Gradle, and we have our normal source set. And we need our JVM bindings. These are those. And that's it. We have external override fun whatsoever, yada, yada, yada. That's how you patch normally GNI and JVM. That's it. That's no magic. That's not complicated. You can just do it. But do yourself a favor. Use interfaces for that, because if you want to test with that, you can skip or you can just fake the invocation at a caller. Do yourself a favor. Define an interface which defines the methods you want to use. OK. Fair enough. Easy enough, right? So let's go to the next thing. What's the next thing? Our all favorite, JavaScript. We all love JavaScript, right? I did it a lot in my life, too often, I think. So what we here do is also super simple. We use wasm-pack, which produces from the Rust code wasm, so which we then can load in the front end from a browser. And if you know, we have something like Kotlin.js. We can just load it at runtime. That's great. The other thing we need is a little bit understanding how promises in JavaScript work. That's it. And if you ever had to work with Kotlin.js, you actually know that. I'm pretty sure of that. And the last thing you know is how to set up Webpack. And if you ever use something like SQLDelite in your project for Kotlin.js, you already have all the knowledge you need. That's all you need. So let's look at another portion of code. So where is the Rust code? I can tell you, it gets from here on very boring because it's basically the same. We have here some annotation which simply say, oh, here, use that when it's only Rust, and some variables and some stuff. That's not important. This just tells the compiler here, please produce some bindings for JavaScript and wasm out of it, and that's basically it on the Rust side. And what we do on the Kotlin side is something else. Where is it? There is it. So what we do basically here is loading this wasm library. That's how you did it at least 6 months ago. That's what I said. That's why I said we need promises, because we can just we have to load it and then can just do stuff. So we have to make an invocation over a promise, and the rest, well, easy enough, right? That's Kotlin code you can read and understand. No black magic involved. And one thing I have to mention here: the entire thing has to be suspending, just because we load here at runtime a wasm code. That's not great, but that's how it works for now. Maybe in the future we can skip that, and then we have a synchronous call or not an asynchronous call, which would make the invocation and integration much easier and cooler. So, and let's come to the last part. native. Did you ever make Kotlin native? I know you do. Yeah, you do. You feel pain every day, right? Yeah, I feel you. So what we do here is something else. We write a C bridge. If you ever did that in your life, you know it's even worse than Kotlin, Kotlin native, because that things tend to break very, very easily. The second thing you have to do, which I didn't put in there because it's the Kotlin native thing, you have to know Kotlin native itself, how you set it up, how you work with the definition files, how you make it work in your setup, and that's painful enough. That means, in the end, you need a lot of time, patience, and hard nerves to deal with that. It's really just sometimes to run out of a room screaming. And please do if somebody says he needs a Kotlin native library. So how that looks on the code base. Also very easy. I feel like I repeat myself now. And we have here the native bindings. And you see, that's it. We have an annotation which says no mangle. No mangle means, in the end, just don't mess up the symbols. Just take them right away without doing something fancy. And that's actually important because otherwise the compiler can't link it correctly together. We say here also it's a public method. It's extern. We want to have a C. So that's our C bridge. And that's basically it. That's a pointer. You might have seen that if you ever, that's a string pointer. You might have seen that if you ever wrote C. And we also give a C pointer back. Why we do that, I explain at a later point. So, and the boring part is how it looks in iOS main. It's something like that. We call the method, we do something, we decode the string back in our system, and that's something bad we have to do. We have here to care about memory because it's a C bridge, and that's typically something you don't want to do. We have to here actively free memory because memory is managed on the Rust side, but we use it on the Kotlin side, so we have to do here something actively. But that's actually super nice from Kotlin that you can have extension function and just put it everywhere there and don't care about it all. The only thing you really have to care about that this thing is everywhere. That's fair enough, I think. That's a good compromise. So that's basically it. Now we can use it in all the Kotlin-Multiplatform targets. Great, isn't it? So, what else do we need? I said it. We need a little bit of Gradle magic. I spare you that because that's really a mess. Yeah, sorry. We need a data handling strategy. That's what I meant. That I use their string pointers is for a reason. Because dealing with complex data over a C bridge, you don't want to do. Because you will, for let's say 99% of the cases, do everything wrong. Just serialize the data, put it into the other layer and deserialize it. It's fairly fast enough and use it from there. It's much easier. It spares you a lot of complexity and mental overload. Use something maybe like protobuf because you can then use the definition on both sides and the generator will take care of that. You can use something like JSON, where you also can have a JSON schema and a generator takes care of that, produces for you the deserializer and you are fine. But please, don't try to use directly complex types. That also goes not only for native, that also goes for JVM and also for JavaScript. You will otherwise do certainly things wrong. I promise you that. Yeah, build concise interfaces. You really want to narrow down the problem on a smaller level and chunk it down. So, and you don't want to create bottlenecks, stuff like that. Just be concise. Write tests. That's a hard learning if you never had that, but you will end up debugging a lot of cases if you don't have that. So I normally use TDD as a technique, so I not so often run into this problem, but I know it from coding camps and stuff like that, where people don't do that. They're sitting there the entire day and try to figure out what's wrong with that, and you can avoid that. And if you make something over 2 technology stacks, you want to avoid it because you don't have a debugger in Rust for mobile. Just by the way. So traps and pitfalls, yeah. Debugging, have fun. There's no debugger. Yeah, that's intuitive, right? A C bridge on native, you have to do handiwork. That means you will produce errors. That's I also told with the answer invocation in JavaScript. Complex data, yeah, don't do that. Just don't. Concurrency. I didn't talk about that one, right? Co-concurrency in Kotlin is great. We have coroutines. We have a hierarchical structure. So that means we can have our view model and say from the view model scope out, cancel please every child you have there. You don't have that in Rust. So you have threads, plain old threads. There are some coroutine models which you can use in Rust, but they are not official. So support is sometimes a little bit iffy. That means you have to settle down where is responsible if you have to do asynchronous work. And just an advice from me, do it in Kotlin. It's much easier. So what else? It's a green field, so have fun finding material because there is none. We all been there, right? It's like with Kotlin compiler plugins. The other thing is the learning curve. Because if you never touched Rust before, it will be a pain. I guarantee you that. I've been there myself. I need to come to an end, right? OK. There's a term for that, which is well known under Rust developers. It's called the Valley of Tears. We all been there. Have fun. So. And I bet there's more, but I have a little bit time pressure. I really thought I finished the talk in 30 minutes, but I didn't, obviously. Helpful things, that's all links, which you can take from the presentation directly. Google just released their comprehensive Rust repository. It's great. It makes so many examples. You can train over that Rust. And that's another thing which happened over the last year, which you might not aware of. But all the big companies are adopting right now Rust. That means Google. That means Microsoft. 1Password, for example, their entire app is written in Rust under the hood. Only the front end is patched in something like TypeScript. Everything else is Rust, completely. So the hype train is already running. Mara Boss is one of the big Rust icons. Check her out, and especially her article about atomics and logs, because she helped me to understand how to use atomics and logs in Kotlin via Rust. Because Rust is very concise, you have to know what you are doing there. In Kotlin, sometimes not so much, but she will explain it in a very good way. And then you automatically know how to do that in Kotlin. That's great. The official Rust learning resources are super, super great. I wish we have the same for Kotlin, to be honest. And that's a nice channel, no boilerplate. Please check him out. He's a super nice guy. And you can always come to our meetups, right? There are a Rust meetup in Berlin. There's a Kotlin meetup. We have a hacking, or every 2 weeks we hack together. So just join us. And we can discuss problems there. And beyond the talk, there's auto-generator, something like UniFFI. Trixinity is actually an app for, I think, what is it? Not Mastodon, Matrix, where they have a product solution which uses Kotlin and Rust together in multi-platform. So you can check out their code base, how they did it. TypeShare is a library from 1Password. This is what they actually use to bridge Rust code with different front ends. And GUI is a UI implementation written for Skia, and now I really want to scare you, which is working right now on iOS, desktop, for Linux, Windows, something else, not on Android, but they are going there. So, and that means you can do even the UI in Rust if you want to. And are we GUI yet? You can check out the latest libraries. And last one, there was a Flutter talk for Flutter and Rust. If you want to do Flutter, you can also use Rust. That's great, right? Isn't it? So now I'm open for questions if there is time. How many time we have? Oh.